In this video tutorial, I just want to explain how we have things set up here for our little fuzzy inference system for elevation uncertainty in the EM's program. So this is an offshoot of DoD3, which was all in MATLAB and requires the fuzzy logic toolbox. Fuzzy logic toolbox in MATLAB, when it's installed, shows up under toolboxes, fuzzy logic. All that actually does is give you direct access to the help and then a couple of GUIs. You can get to all of that if you go to your MATLAB folder on your machine. You actually don't have to have this installed if you have the right files. You can go to Program Files, MATLAB, the version that you're in, and then toolboxes. And so if you simply had the fuzzy logic toolbox and you copied it into the toolbox folder, these things right here would give you all the necessary files for this to run. What I'm going to show you is three M files, and these are little MATLAB codes that we've written to help you run fuzzy inference systems. If we go into where I've got these hiding, and you'll be able to download a zip file that has these files. We've got basically FIS IT, IOE reader, this FIS DEM1, and then this inputs, and then the saver. Those are the things that actually matter here. And we're gonna look at this code real quick here. So here's these files, and so the way this is set up, we've got the main program here. This used to be nested inside a big long wizard program in DoD3, and what's going on is that in GCD 5 currently you can only have fuzzy inference systems with up to 3 inputs. What this allows you to do is run fuzzy inference systems that you might have set up on your own that have up to 7 outputs. So what the code does is first off just establishes the root directory where your code relies, and then it goes in and you load up a fuzzy inference system. It brings up a dialog so you can load that. Once it's read that in, it asks you where are the inputs that you're going to use for that inference system stored. So for example, if you're making elevation uncertainty FIS and you've got 4 inputs that say slope, point density, vegetation height, roughness, etc., you could then get those all in one directory, and then this will just point the program to that as the default. You'll still be able to navigate if you can't find it. Then what we have here, this is the basically where the FIS that was loaded by the user here actually gets read and created as a fuzzy inference system object. Then we go into the reader program, and so this calls up the reader, and inside the reader we basically look at the fuzzy inference system that the user specified and determine how many inputs there are. And if there's, you can have between 2, it doesn't make any sense to have less than 2, and up to 7 are allowed in here. The code is easy to extend if you want to. And what that does is it basically grabs the names of those inputs out of your inference system. So let's say they were slope, point density, roughness, whatever, it would assign them to these variables. And then this little FIS reader for the inputs just runs through a loop, and so for as many inputs as you have, it's going to go through and it's going to tell you this is the input you need to load. So it might come up and say slope input raster needs to be loaded, and the next time through the loop it'll say point density needs to be loaded. They have to be ARC ASCII grid files, and then it just reads the file in. And if it's the first time through, it just records what the number of rows and columns are to check for concurrency. And then the next time through and all subsequent times, it's just checking to make sure that they're concurrent. After that, puts all the rasters in a big stacked array, and then once it's done loading all those inputs, spits us back to this program. In here then, the next block is it evaluates the inputs using fuzzy inference system. So what it's going to do is it comes in, and based off of the number of inputs, whether there were 2, 3, 4, 5, 6, 7, it's going to run and evaluate that fuzzy inference system based on the inputs. So notice here, right here, it's grabbing, it's going to store the output into this uncertainty grid FIS, and it's grabbing this FIS1, FIS2. These are the input 1, input 2. On subsequent ones, it's grabbing 1, 2, and then 3 inputs. And all this is basically just to clean up the no data cells and make sure that we're only doing calculations where we have data for all of our inputs. So it runs through that depending on how many inputs you have, and then it's stored now in this uncertainty grid. It's stored all the data. What this line here does is converts that from a raster sort of format with rows and columns into a single column array that then can be used to calculate statistics off of that. And so some basic stats are recorded, and then we call up this IO saver, DEMFIS, and what that IO saver does is simply asks you where you want to save this file. Goes through, writes the file. This part, because this isn't vectorized code, this isn't a nested for loop, actually takes a long time if you're dealing with big grids, but that's what you have to do to get this damn ASCII format correct. And then after that, it produces a real simple metadata output report. Then it spits us back when it's done to here, and then the program's complete. So that's all there is to the code. In another video tutorial, I go through how you use it. You don't need to know all this stuff in the code, but those of you that want to tweak the code, this long-winded monologue is just here to help you understand how this was set up and catch ridiculous spelling errors, I guess. Alright, have fun.